Good morning, A2 students. So we're continuing on with our notes from 3-3 about isosceles triangles specifically. So the altitude, which when we talk about the altitude, we're really just talking about the height of a triangle. That straight up and down that makes the 90-degree angle with the base, that triangle, that's the altitude or the height. So the altitude of a triangle is the line segment from a vertex, so from one of those corners, that is perpendicular to the opposite side. And just a little review, when we say perpendicular, we mean forms that right angle. So you can see in our first diagram here that we have an altitude that is drawn outside of the triangle, which is totally okay. That's still an altitude, totally allowed is what don't know what I'm trying to say here. And then we have an example of an altitude on the inside of the triangle where it's coming from the vertex B up at the top, and you can see it makes that 90-degree angle with the little box down at the bottom there. So those are both examples of altitudes. What's really important about the altitude, and the piece that you're going to want to highlight, the piece that you're going to be needing to use for your notes, or not for your notes, for like your practice problems and stuff, is that in an isosceles triangle, so remember an isosceles triangle has two equal sides and two equal or congruent angles. So in an isosceles triangle, the altitude from the vertex angle, remember that vertex angle was the one at the top that isn't equal like the two base angles. The altitude from the vertex angle, so keyword here, bisects. And hopefully you remember the definition of bisect from Unit 2. If not, jot in that bisect means to cut into two equal parts. So that altitude is going to bisect both the base and the vertex angle. So for example, if this was a isosceles triangle here, that would mean that AD would be congruent to DC. However, this is not an isosceles triangle, which is why it doesn't look like it is. Here is a better visual of that. In this diagram of triangle ABC, you can clearly tell that it is isosceles because of those markings. So let's make a note of that. These markings mean congruent. Those markings mean that those two sides are congruent, that side AC is congruent or is the same or is equal to CB. We can see that we have that altitude CD that's being drawn in the little 90-degree angle box to reassure us of that. So that tells us that that red altitude cuts the base into two equal parts. So we know that AD is equal to DB in this situation. We know that AD is equal or congruent to DB. Just like we know that AC is congruent to BC. So we'll look at example 2 in the next one.